Good morning everyone. Welcome to Mood Techie. In today's session, we are going to learn about the distinctive features of tropical dairying. This topic is an important part of dairy technology education and helps us understand how dairy systems function under tropical climatic conditions. We will go through the environmental, production, quality and management aspects one by one. To start with, let us look at the basic idea of tropical dairying. Tropical dairying operates under hot and humid climatic conditions. These systems are also strongly influenced by seasonal variations. Another key feature is adaptability. Dairy animals and management practices in the tropics are adapted to survive and produce under environmental stress. Therefore, tropical dairying is shaped by heat, humidity, seasonality, and adaptive farming systems. To understand these systems better, we must look at the environmental conditions in tropical regions. The average temperature generally ranges between 27 and 31 degrees Celsius. This temperature is already close to or above the comfort zone of dairy animals. Relative humidity remains high, usually between 70 and 85%. Such high humidity increases thermal stress. The temperature-humidity index often exceeds 72, which indicates stress conditions. Many tropical regions also experience seasonal drought lasting several months. These climate metrics define the stress environment of tropical dairying. With this climate in mind, let us examine the effect of high temperature on milk production. High temperature leads to heat stress in dairy animals. As core body temperature rises, animals struggle to maintain thermal balance. Feed intake decreases because appetite and rumination are suppressed. This directly reduces nutrient availability for milk synthesis. As a result, milk yield shows a significant drop. In addition, milk components such as fat and protein percentage also decrease. Thus, high temperature negatively affects both quantity and quality of milk. Along with temperature, humidity plays a major role in milk quality. High relative humidity slows down natural cooling mechanisms. Evaporative heat loss becomes inefficient. Because of this, microbial growth in milk increases rapidly. Psychrotropic and spoilage bacteria multiply faster. This leads to early spoilage and reduced shelf life of milk. Therefore, humidity directly contributes to milk quality loss in tropical regions. Another important concern is milk spoilage risk under tropical climate. High temperature and high relative humidity together create ideal conditions for spoilage microorganisms. Bacteria such as Pseudomonas, coliforms, and Bacillus species multiply rapidly. These organisms reduce milk safety and storage life. Due to this rapid microbial growth, milk has a very short shelf life if not handled properly. This highlights the seriousness of spoilage risks in tropical dairying. Apart from climate, infrastructure limitations also affect tropical dairying. Many dairy animals are housed in open barns. Such housing provides limited protection from heat and humidity. Cold chain facilities are often weak or incomplete. This affects milk preservation after milking. Power supply gaps are common in rural areas. These gaps limit the use of cooling and refrigeration systems. Water availability is also restricted in many regions. All these infrastructure challenges reduce dairy efficiency in the tropics. Because of these conditions, several management challenges arise in tropical dairying. Heat abatement becomes essential. Sprinklers, fans, and shade systems are required to reduce heat load. Seasonal fodder management is another challenge. Farmers must manage fodder shortage during dry season. Breed selection is also critical. Heat-tolerant breeds and crossbreds are preferred in tropical regions. Udder health requires special attention. High humidity increases the risk of mastitis and infections. Due to high spoilage risk, special handling and preservation methods are required. Rapid chilling of milk to 4 degrees Celsius is essential immediately after milking. Clean milking practices help reduce initial bacterial load. Humidity plays a crucial role in milk safety. Insulated transport is required to maintain low temperature during movement. Pasteurization methods such as HTST or UXT are necessary to ensure milk safety and longer shelf life. At this stage, let us compare tropical regions with developed regions. Tropical regions experience high heat and humidity. Feed scarcity and weak cold chain are common problems. In contrast, developed regions have cooler and more stable climate. Feed quality is consistent and infrastructure is robust. This comparison clearly shows why tropical dairying requires special management strategies. This slide provides a visual summary of the distinctive features of tropical dairying. Environmental stress is characterized by high temperature, humidity, and THI stress. Production is affected due to reduced feed intake and lower milk yield. Milk quality faces higher spoilage risk due to microbial growth. Infrastructure gaps highlight the need for better cooling and cold chain. Finally, we come to the end of this session. Understanding the distinctive features of tropical dairying is essential for improving milk production under hot climate conditions. Thank you for learning with Mood Techie. Keep exploring and keep learning.